Hey, what's up, everybody? This is Ray, and welcome to the RayWenderlich.com podcast. In this podcast, we'll keep you up to date with the latest app development tech talk. Now, here are your hosts, Drew Freeman and Alex Sullivan.
Thanks, Ray. This is the Ray Wenderlich podcast. Welcome to episode 4 for season 10. And this episode was recorded on Saturday, the 21st of March. Happy equinox, everybody. For release on the 8th of April, 2020. This show is sponsored by The Bug, Paratrachina longicornis, and by the Singleton design pattern, whether you like it or not. I'm Drew Freeman, here with my crazy aunt co-host, Alex Sullivan.
Thanks, Drew. This episode, we welcome Filip Babić, co-author of Kotlin Coroutines by Tutorials. Filip is a professional developer with extensive knowledge of Android, Kotlin, and Java. Developing since 2015, he's amassed a great deal of experience and finished projects using only best practices, building high-quality products. He's a huge Kotlin lover and preacher, mostly focused on Kotlin coroutines and other low-level concurrency mechanisms.
On this episode, Filip is going to be giving us the ins and outs of Kotlin coroutines. Later, Alex, in preparation for our upcoming Flutter show, will talk about his delving into some Flutter. Filip, welcome to the show.
Thank you for having me. Hello.
It is great to have you on the show. You were with us on the Google I/O Livecast last season. Yeah. And right now, it doesn't sound like there's going to be a Google I/O Livecast this season because Google I/O is basically saying, we're not doing anything.
Yeah, it's crazy. You know, last year when I was there, it was my first I/O. And it was just amazing to see like thousands of people gathering together and talking about our favorite things, technology, Android, and other topics. And it was really cool to see all the new products, all the new APIs for Android, and so on and so forth. So I'm really curious to see if there's going to be any kind of I/O. But as you mentioned, that we might not have one this year.
Yeah, it's for historical purposes, for people reflecting back on the show, people watching or listening to the show now realize that California has just gone down in lockdown for the coronavirus, and that's going to hit Google. We probably will hear the same about WWDC coming up soon. They've gone to a completely online show. We talked about that some last week on the last episode, excuse me, and it's just remarkable what's going on. Filip, where are you located?
In Croatia, in Europe.
And how are things there with the virus?
So people are going into lockdown as well. We have government issues safety measures, so we can't really go outside for the next month or so, or at least shouldn't. All groupings of more than 5 people are kind of banned, so to say.
5?
So, yeah, it's far more, or actually, if you're under 5 and if everyone is safe, so if no one is interacting with, a bunch of people, then you should be fine to hang out, but only at your homes. So it's a bit crazy, but those measures are really good because we haven't had a lot of cases, only up to 100 and something, I think. So the contamination is kind of spreading really slowly, and we're trying to stop it overall. So it's not as crazy as some parts of the world, but we're still doing precaution.
And of course, we hope during this time that everybody is staying safe and following general governmental orders, and the fact that we can get through this and start having conventions again. Well, that's it. We're just everybody stay healthy so we can have another Google I/O and WWDC. So, strangely enough, normally what I ask is, what do you do when you're not coding, and possibly there are other people to interact with?
Ironically enough, I do a lot of conventions and I do a lot of public speaking. So, for example, I did about 10 or a dozen conferences last year, or in the past 2 years. So I've been traveling around, kind of had an idea of cutting back on conferences, which is starting to happen by itself.
I guess, yeah. This is a good time to make that resolution.
Yeah. So other than that, I organize a lot of initiatives in the community here in Osijek, so like a local community. For example, we do the Android Academy initiative, where we gather 20, 25 students I say students, but it's just, people of all ages, to teach them Kotlin and Android to help them get IT jobs or maybe first internships, things like that. I used to do a lot of writing, but I haven't had the time for that as I'm finishing college as well, just finishing my master's degree. So yeah, there's
a multifaceted man.
Yeah, a lot of things going on, and currently I'm mostly in my home doing work, recording videos, as you can see, and occasionally hopping on podcasts.
All right, so we've talked about the computers, the conferences, the writing. Is there anything non-computer for fun that you do?
Yeah, so that might sound a bit sad, but yeah, I do non-computer stuff, although it's still quite geeky. So I play Magic the Gathering, and I play D&D with my friends. So it's all the nerdy stuff.
How would you describe your favorite Magic deck?
Oh, okay. So my favorite one is an Eldrazi deck, which is probably why people hate me when I play it. But I'm still new. I've been playing for, I think, about 5 or 6 months. I'm trying to build up new decks and everything, so I'm still trying to find myself, I guess. But big creatures hitting people in the face.
By DMing, are you talking classic Dungeons and Dragons, or are you DMing something else?
So I did one one campaign where I DM'd, and it was Lovecraftian inspired. But now I'm playing, and my friend, I'm just a player, and my friend is a DM, and we're doing this kind of Adventurers League kind of game where every session is like a mini mission for itself, and we're trying to gain more traction and more fame through the Adventurers League. So it's really cool.
Are you trying to do the dungeon, the DMing and the D&D and the like? Are you trying to do that virtually now, or is that just sort of on hold?
Yeah, so it's a bit on hold, but then again, there's only about 5 of us who play, so we're allowed to gather up and play together.
So you're right under that limit.
Yeah, just right under that.
What happens if there's 6? If there's a mom and a dad and 4 kids, you have to kick one of the kids out?
Yeah, that's it. Now you have 3 kids.
That's it. 5 is the maximum. Yeah, I think Pennsylvania, the state I'm in, just went down to 10. So it's crazy out there. Let's talk about something a little more uplifting. Let's talk about Kotlin Coroutines. Can you give me...
Yeah. Very uplifting.
Give me the 40,000-foot view of what Kotlin Coroutines are.
Okay, so a lot of people, when they look at Kotlin Coroutines, they see something really, new and crazy and different from everything else they've experienced, I guess. But in fact, it's actually really simple when you get down to it. It's just a way to run your code which supports functions which you can pause and resume at a different point in time. So, for example, I like to compare it to everyday activities. For example, cooking. If you're baking cookies, you can just put them in the oven and forget about them for 20 minutes, half an hour, or even more. And then you come back and you pick up those cookies and you can eat them. You can think of coroutines as a similar concept where you can run one function and then just let it run in the background, so to say. You pause it, or at least suspend a part of it, and then you proceed to do something else. Once the, let's say, the data you are trying to fetch or the value you're trying to compute or something like that is finished and ready for you, you can just pick it up and continue with your program.
That is a great analogy.
Thank you.
I mean, I've been looking for a good analogy of asynchronous in general, and that's just lovely. And you get cookies.
And you get cookies, yeah. You can also compare it to making a sandwich or just boiling something. The analogies are just out there.
Oh, Alex is going to come in with avocado toast now.
That is true. You could compare it to making avocado toast, and should. So I guess one thing that I find it kind of hard to wrap my head around is when you're using coroutines, how is it fundamentally different from when you're doing stuff in a non-suspending world? Let's say that I wanted to, make a network call to get some data and then to show it in the UI. How would that work in coroutines versus using, I don't know, an async task or anything else in this world? In this crazy world of ours.
Yeah, crazy world of Android. So it's not essentially that much different from other concepts, but it does let you do some cool things. For example, when you're using an async task, or maybe just go even simpler and creating your own thread or a runnable. You're essentially creating your own threads or new threads and allocating more memory to run those tasks. Then when you do run those threads and finish some other function and you go back to your previous code, you have to worry about either callbacks or maybe even starting a new thread or posting back to the main thread. So there's a couple of things that are going on there, and you have to do everything manually, more or less. Coroutines kind of want to help with all that and let you do as little as possible, or at least make you do as little as possible. So when you do start a coroutine, there are different dispatchers or dispatcher instances, which are actually thread pools. So you don't have to worry about creating your own threads or even like choosing which thread pool you're going to use. They are predefined for you and optimized in some way. Then once the value is computed and you get it back, you can use it. You don't have to worry about pushing to the main thread using, for example, run on UI thread or something else. You can launch another coroutine which uses the main thread dispatcher or something like that, and then it does so for you automatically. And when you get even deeper into coroutines, you don't even have to do that. All you have to do is run one coroutine and fetch a piece of data from a different thread using a different builder. So all the threading mechanisms, synchronization, and so on and so forth is executed by the coroutine mechanism. Now, that's not much to begin with. It's just a smarter way to deal with threading, which is why there are other things as well. For example, the cancellation policy. If you're working with threads manually, or for example, an async task, or even retrofit, in general, retrofit callbacks, there's all these things you have to do about cancellation. So if the user leaves a screen or the request fails and things like that.
And that's so you don't leak memory or something.
Yeah, so you don't leak memory, so you don't cause overhead. And that usually works fine, but it's very easy to leak memory, as you know. So coroutines try to circumvent that by adding a special cancellation policy within the mechanism. So what happens is if you start one coroutine, for example, and you start it on the main thread, you can create a new smaller coroutine within that piece of code, which will fetch, for example, the user from a backend service. If you cancel the main coroutine, the fetch from the API service will be canceled as well. Because of the suspend mechanism and because the system knows how to send the signal to a thread, which says, okay, this coroutine has finished, you should stop now. Now, there are different ways you can do this and different ways this functions depending on which coroutine builder you use or which dispatcher. But more or less, it's pretty safe and it works out of the box. So you don't have to worry about cleaning up resources after you start an API call.
Well, that's pretty magical. That definitely gets rid of a lot of extra boilerplate code. So you mentioned dispatchers and coroutine builders. What is a dispatcher? And I think that relates to another confusion I have, which is, I've heard of coroutines kind of talked about as a replacement for threads, but they actually sit above threads, right? Or what is the relationship between a coroutine and a thread? I think I just asked 3 questions. So.
Yeah, I mean, so that's kind of the reason why some people think coroutines are magical or hard to get into. Once you start learning about them, there's just so many questions going around, and there's quite a lot of concepts you have to grasp. But if you go one step at a time and you examine one concept at a time, you should be fine. You should learn it pretty easily. So a coroutine is often described as a lightweight thread. The reason why it's described like that is that it doesn't necessarily create a new thread. It just uses the thread pools in a very optimal way. For example, you can launch hundreds of thousands of coroutines, and they will perform they won't block the UI or won't create a lot of overhead to block the application in general, or maybe burn your phone or something like that. The way things work is every single coroutine gets a dispatcher, which is essentially like a replacement for a thread pool, or just like a so if you can compare it to other mechanisms, you can compare it to a scheduler in RxJava, for example, or an executor in Java in general. So it's just a mechanism which says, okay, you have this piece of code and we want you to run it in this thread pool. You can do your scheduling from there on. The dispatcher communicates to the operating system, and then the operating system schedules those API calls or functions which are on the stack. So you don't create new threads, you don't create a lot of overhead. There's just a bunch of function calls in the background which the system then optimizes and schedules for you. So they're much better, or I wouldn't say necessarily much better, but they are better because they give you the ability to communicate to the system more directly compared to other mechanisms which are pretty high level, if that makes sense.
Yeah, it does make sense. So dispatchers kind of match to, are they like a direct mapping to thread pools? Is the IO dispatcher just like, yep, this is 4 threads or whatever sitting in the background, or is it a little more complex than that?
So yeah, it's a bit more complex, but when you look at it in like the bare bones and everything, it's just a way to communicate to the system which thread pool should be used.
Cool. Okay.
Of course, so the dispatcher kind of also describes how the thread switching is going to happen, and that leads to the thread pools. So for example, the unconfined dispatcher, which is a bit weird when you look at the documentation, is a dispatcher which doesn't necessarily have a thread pool behind it, but instead it says, okay, if this coroutine should switch to a different thread, just leave it as is. Don't switch to a new thread, just keep the current thread running the code. So,
interesting. Yeah,
so they are not directly relatable to a thread pool, but they communicate to thread pools whether a function should run in the IO thread pool or the default thread pool or the main thread.
Okay, cool. That makes sense. What about coroutine builders? What are they like? How do you do a coroutine?
Yeah, so just like the name states, a coroutine builder is just a function which builds a coroutine. And they are essentially simple functions which take in a few parameters. They can take in the coroutine start parameter, which is just a way to say if your coroutine will be started immediately or lazily, when you call start yourself. Then they take in a parameter called the coroutine context, which is another topic for itself, but essentially it is a set of rules the coroutine will use. So one set of the rules you can pass in as the coroutine context is the dispatcher. And another set of rules is the coroutine exception handler, which handles exceptions. And a third set of rules is the coroutine job, which is essentially the piece of work as an object, represented as an object.
Interesting.
So
kind of like
you can
a
pass that in,
runnable or something?
Yeah, kind of like a runnable, so to say.
Okay, cool.
Which you can cancel, of course. And then the last parameter would be the actual block of code, the Lambda block, that you want to run in a certain thread or thread pool.
Okay, cool. And are there, so do you have to supply all of that stuff whenever you're launching a new coroutine?
No, so most of the parameters have default parameters or default arguments. The only parameter you have to, or argument you have to pass in is the Lambda block, because it kind of makes sense, you can't run a default Lambda block for a code.
Yeah. What code are you running?
Yeah, just a print statement or something. Yeah. So you have to pass in like a Lambda block. The start parameter is, the default one, which is immediate execution. So you don't have to start the coroutine yourself. The context parameter is the default context, which is essentially empty, but it pulls the context from the coroutine scope you're using, which is another concept. Yeah, another concept. So basically, the default context is, okay, I have a context within the scope of things I'm doing, and just take that. You don't have to change anything. So for example, if your current coroutine scope is main thread bound, it means the coroutine will be main thread bound as well. If it's IO dispatchers bound, it will be in the background by default.
Okay. So it just takes like whatever the parent is or whatever it's within.
Yeah, it inherits the parent.
Okay, cool. So if you so that implies to me that you can like launch sub coroutines within coroutines, and then it kind of just trickles up.
Yeah, so once you launch a coroutine, which so you need the coroutine context if you're trying to configure it in a different way. You need the start parameter if you want to start it lazily or you want it immediately. You need the Lambda block to run some piece of code, and you need to run a coroutine or launch a coroutine on a coroutine scope. I mentioned this. So the coroutine scope, a scope, as the name states, is like a fixed timeline or something like that, which just says how long the coroutine will run or when it will be canceled. For example, you have the global scope, which is just a general scope which runs as long as the application runs. A good usage for that will be if you have some upload task or something which you don't really expect a result from. You can launch a coroutine in the global scope, and it will run as long as the app runs. So it can upload for you in the background. But you also have custom scopes. You have scopes which run as long as the activity is active, or a fragment, or a view model if you're using architecture components. So basically, they are used to help that cancellation and just to avoid any leaks. So once you launch a coroutine, if the scope dies, so to say, if the activity is destroyed, then the coroutine will be canceled as well. So to clean up resources.
Oh, cool.
Yeah.
So that's kind of like, sorry.
Yeah, and once you, just wanted to mention this, and once you launch a coroutine on a coroutine scope, it inherits the context from the coroutine scope. And then each coroutine builder usually has a pass parameter called the coroutine scope, which inherits from the parent, and then you can call nested coroutines, as you mentioned. So.
Okay, cool. And so that kind of sounds like if we're in maybe RxJava world, which hopefully a good number of listeners are familiar to, you would get a disposable back when you subscribe to something, and then maybe an on destroy of your activity or on clear to your view model, you'd dispose of that coroutine. So the scope sounds kind of similar to that, where there's like, it lives for that amount of time and then eventually it gets killed.
Yeah,
right?
So it's quite similar, but the scope itself uses an internal mechanism for that, which is called the job, as I mentioned. It just creates a parent job which can be canceled. And as you can launch a coroutine within a coroutine, you inherit its job essentially, and then you have like a job hierarchy. So once a single job is canceled within the hierarchy, everything gets canceled. Unless you use specific jobs which are called supervisor jobs, and then you don't really, they supervise their children, so you don't cancel the parents if the child fails as well. So it's kind of like a disposable bag in essence, but it actually composes like a couple of different mechanisms. So both the disposable bag in form of a job, the exception handler which handles exceptions which you didn't catch in the coroutine itself, and the dispatcher or threading, which is whatever you want it to be by default. So it's a bit more than just a disposable bag.
There's a lot going on. It's very interesting.
Yeah.
So one thing that I'm still trying to kind of wrap my head around is, from what I've seen, one of the main benefits you get from using coroutines is that you get to write code that uses different threads, kind of like it's just normal code. So like I've seen examples where you say, val my dogs equals fetch dogs from network, and then next line right below that, my list, set my dogs with the new dogs. And normally, from what I'm used to, you'd have to, make an async task or use RxJava to get a callback when it's done, fetching the dogs, and then you'd have to make sure you're back on the main thread, and there's a whole kind of like dance to it. So does coroutines just let you like escape all of that and just normal code?
So the answer is kind of yes and no.
The best type of answer.
You always have to launch a coroutine before you use something called a suspend function, which is another term for its own. So every coroutine can be suspended. And as I mentioned with the cookie example, you can suspend a coroutine and let a piece of it run in the background. And then once it's ready, you can resume the code and continue on. So if you think about it, what happens, what's the prime example, for example, let's say, you launch a coroutine, which is on the main thread. It uses the main dispatcher. And you would think that if you have a blocking call on the main thread, things will go wrong, right? But if you call a blocking function, which is also a suspend function, for example, a retrofit request, what will happen is the parent coroutine will be paused and main thread will be released. So the main thread can draw the UI and do everything the main thread does. And then once the call finishes, you can the signal from the background thread comes back to the main thread, for example, or the coroutine. And then it seems as if you're just calling a blocking call on the main thread without any consequences. But and that's where the magic happens. So you're not essentially blocking the main thread, you're releasing it, suspending the coroutine which wraps around the main thread. And then once the value is fetched, you can continue just writing regular code, which you mentioned, you just call val something equals, API service fetch this, and then the next line of code is whatever you want to do with that piece of data.
Wow, that sounds like it just simplifies so much.
Yeah, I mean, it's a cool concept, and it's very weird when you look at it for the first time or the first 10 times even. But in essence, it's just a smart way to communicate within the system itself. It's just a bunch of signals from one thread to the another thread or the main thread to synchronize things. Very cool.
So I've one thing, a term I've also heard in connection with coroutines, or as the community discusses it, is like AsyncAwait. And I don't know if you've used like JavaScript or anything like that, but they kind of have this mechanism where you'd say, await my thing, and then do something with that thing, and await my other thing, and that sort of thing. Do you have to do anything like that within coroutines? Do you have to specify like, wait for this suspending function to complete, then give me something, or does it all just flow?
So AsyncAwait is apart from Kotlin Coroutines, which is kind of what we're talking about here, is quite a common concept actually. So C# has it as well. I think Python has it, and even C++ or C have it on like a framework basis or a library basis. So it's very often, and it's quite a popular concept. You can do the same thing in coroutines, and as it's one of the coroutine builders. So basically there's a couple of coroutine builders. There's the launch, which simply launches a coroutine. It's pretty dumb. It's fire and forget, so to say. You have the with context builder, which says, okay, take this context, which is usually a different dispatcher to switch to a different thread, and return a value from this coroutine. So you usually use it to fetch something from the API or the database. And then there's the AsyncAwait builder, which should be used when you have multiple things you want to run in the parallel. So what you do is you create multiple different async blocks. The async block creates or uses a dispatcher and uses a thread from the thread pool to launch the call immediately. And then, it's being processed in the background. So if you create 3 or 4 or 5 or, any number of async calls, they will essentially all start at the same time. But once you call await on any of them, it suspends the parent coroutine and waits for the data to be compiled. So what you can do is create 5 different async calls and then await them all in one place. For example, a new function call. And basically, the await call or the suspension will be as long as the longest call is running. So, for example, if you have 5 different calls and 3 of them are 1 second calls, one is like a half a second, and one is 5 seconds, it won't take whatever the total number of seconds that is, 8.5. It will take only 5 seconds.
Fast math.
Yeah, quick math. It will only take 5 seconds, which is the longest call, as you're just suspending for the longest call and waiting for it to finish.
Cool.
So you can do async and wait.
Nice. And that's if you want to like combine everything into one, so that they all are just flowing at the same time.
Yeah, basically, if you have, if you're fetching the user profile and you have to fetch another piece of information, or maybe you're trying to synchronize and combine 3 different endpoints which kind of have the same things in your UI, and then you can combine all of them. Each will have its own async call. You await for all of them at one place, and then once every async call or every piece of value is ready, you just move on.
Cool. Well, that's very magical. So then that leads me to the most contentious issue within the community. Let's say that I'm using RxJava for everything in my app. Should I migrate over to coroutines, or what are some of the pros and cons between kind of the way lots of people are doing it now with RxJava and what coroutines can get you?
So that's always a big question, and I'm honestly
Should I ready my pitchfork?
Yeah, I'm kind of afraid what I'm going to say, because all the people that are going to be knocking on my door.
All right, pitchfork ready.
Pitchfork ready, yeah. But essentially, I can't say a definitive answer to that. I usually say to people that it depends. So, for example, I worked on projects which are kind of, they're not legacy, but they are really long projects, and they've been refactored and improved over the years, but they still have a ton of RxJava within, and just switching everything to Kotlin Coroutines wouldn't make sense. That's for one reason. For the other reason is you don't necessarily have to migrate everything. So you can slowly migrate and just create new calls, new API calls within coroutines, and leave the rest in Rx. You can also translate between Rx to coroutines or the Kotlin coroutines flow, and vice versa. So they are kind of interoperable as well. I guess the best answer would be, if you're working on a new project and you have kind of the freedom to choose your framework, and you had some time to learn about coroutines, I would say go for coroutines. For example, some of my friends have been working with Rx as well, and they just switched to a different position or a different company, and they tried out Kotlin coroutines, and they just loved it, because they say it's much simpler than what they used to have to write using Rx. And I guess that's because mostly, or at least most of the developers which use Rx in their projects use it for the very basic things, which are API calls or fetching from the database. In my opinion, I think that's kind of the overkill, because you can achieve the same thing with even retrofit. You don't even have to use coroutines. You can use callbacks. Even though callbacks may not be the prettiest solution, they are simpler than learning a lot of Rx to be able to use it properly and in an optimal way. So if you have the freedom to try them out on a new project, or maybe just migrate a small bit of code to test it out, then I say go for it. And that's as long as you're just using it for the very basics, which are API calls, databases, things like that. But there are cases where I would say streams of data, and I don't necessarily say Rx in this case, are more useful. For example, if you're doing a lot with Bluetooth or sensors, things like that. For example, I had, or in my former company, there was a project which used, or they built a smart system for houses, and everything revolved around communication via sensors, Bluetooth, so on and so forth. Rx was really useful there, because everything is a stream of data, and you can create complex streams to just handle everything out of the box. So you don't have to do anything manually. In that case, I guess you can go for Rx, but you can also use the Kotlin flow, which is kind of the new thing. So it just depends on, if you have a lot of knowledge of Rx and you've used it for years, I guess that's easier for you. But I wouldn't say no to coroutines. I would say, give it a try. Just see what happens.
So it comes down once again to right job or right tool for the right job.
Yeah.
But there's a newer technology, and if you're starting out, try the new technology and see how it works for you.
Yeah, exactly.
Nice. I think that's an interesting point around, a lot of people in the community have been using RxJava really just to make a network call, or to get something from the database, to do this one-off task that they want to do in a background thread and then get back onto the main thread. And RxJava, I mean, I love RxJava. Wrote a book for Ray Wenderlich about RxJava. I'm a huge fan, but it's definitely that's not the prime purpose of that framework. The idea there is streams of data. So to me, for all these people that are using RxJava in this way, coroutines seems like a no-brainer. It's just, from my perspective, for the limited amount that I've used it, like a lot less code and a lot less overhead.
Yeah.
And then flow is an interesting follow-up case for like, well, when should we use RxJava? But yeah, I think that was a great take on it.
Yeah, so flow is another topic on its own. But I think like one of the next things to ask would be, is flow experimental still? Is it stable? Should I use it or not? And quite frankly, so what JetBrains does is they create the basis of the API, just like they did with Coroutines, and then they proceeded to develop either like certain sections of the API. For example, early in Coroutines, it was actors and producers, things like that. So special functions which create channels and the channel API. And then they see how it fits in the community, in everyday use cases, things like that. So if they are, or at least I think if they are satisfied with the usage, they are satisfied with the implementation, it's no longer experimental. They did the same with Flow. So what they did was the base API, which is literally two interfaces, a flow and a flow collector. And that's stable. And what they did with the experimental part of it is they created several operators. As you have, or not several, but hundreds of operators actually. As you have in Rx, you have the merge operator, the map, flat map, and so on and so forth. So what they are doing currently, to my knowledge, is they are trying to optimize those operators as much as they can to reduce the overhead, to make them as fast as possible, make them as sensible as possible. Because I know that some operators in Rx behave differently on the way you combine them or in which order you use them. They are trying to simplify that with Flow. So some operators are experimental. The base API is not. And as I mentioned, one of my friends who previously used Rx a lot now also is using Flow in their projects or whatever they're working on currently, and they just love it. They mentioned, it's much simpler than Rx, where you create a flow and then you say, okay, I'm going to consume the values on the main thread, and that's it. You don't have to worry about using the wrong scheduler or the wrong order of operators or something similar. So it has the experimental flag, but it's just for the certain set of operators or certain pieces of the API. The base of it, the cancellation policies, the context switching, the thread switching and everything, that's pretty much set in stone and should be fine to work with.
So one thing I think that we didn't quite touch on was what actually is Flow. So it sounds like it's like some parts of it are experimental, but what fundamentally is Flow?
So it's like a coroutine powered stream of data.
Okay.
Well, exactly, that's what it is. So they try to, so it's supposed to be a cold stream of data, which has coroutine support. This means basically that just like with observables, or singles, which don't emit data until you subscribe to them, or don't run an API call if you don't subscribe to them, flows are just like that. You define an operation which is going to build certain pieces of data, and then they wait until you subscribe. Once you subscribe or consume the flow, it starts doing some work using coroutines. So essentially, you have the best of both worlds. You have the best of Rx in a way that you have a cold stream. You have hundreds of operators, but you also have the best of coroutines, where Flow supports cancellation, Flow supports coroutine scopes, so that in turn supports cancellation. They also support the suspend mechanism. So the biggest problem in current streams of data is back pressure, I guess. When you create too many events, or you just can't consume enough of them at some point in time, you either lose on data or have to block one side of the channel, so to say. What coroutines do is they receive the signals for pieces of data, and if the consumer is too slow, they just suspend the producer. So the producer will continue to receive signals, but they will be suspended in a way that they won't send those pieces of data to the consumer. Just like if the consumer is, consuming too many events, is really fast, and the producer can keep up, you can suspend the consumer, and the producer will keep on sending the data while the consumer is suspended, and it will slowly consume those events, so you don't really lose on data. There's always, buffers and things like that which you have to be careful about, but I think they do it really simply that you don't really have to think that much about the whole implementation.
That's cool. So fundamentally, Flow is kind of the coroutines version of like an observable in RxJava. And it has all the benefits of coroutines with cancellation and using suspending functions and all that sort of stuff.
Yeah.
Well, that's cool. I played really briefly with Flow. And one thing I noticed you can do is, a thing I've noticed a lot of beginners in RxJava really struggle with is error handling. I think people tend to want to put like a big try-catch block around subscribing to an observable, which is just unfortunately not how it works with RxJava.
Yeah.
But it turns out it is how it works with Flow. Like you can just wrap the whole thing in a try-catch, which I think is very cool.
Yeah, so you can essentially wrap it in a try-catch block, but there are also catch functions which do what they say. They catch the exception, but what you can do with Flow, and it's a bit different with Rx, you can prepare a different set of information, and then once you catch an exception, you don't have to proceed with that exception. You can simply say, okay, just continue emitting these pieces of values, and then I'll consume the exception later on, or something like that. I know there are operators in Rx which say on error resume with the next value or something like that. But this is, for me, it makes more sense because you simply say catch, and it will catch literally everything which goes down the stream. And then you can proceed to emit values if you don't want the stream to fail. You can just emit something completely different. So in that way, it seems a bit simpler to me than with Rx. But then again, Rx may have more options. You can always say that. So.
Yeah, that's very interesting. Yeah, Flow sounds really promising. I'm excited to play with it some more. That's from a diehard RxJava fan.
One of us.
All right, so oftentimes we'll have engineers from Google or maybe from JetBrains listening to the podcast. If you could ask them anything about coroutines, maybe something to change or something to clarify or something along those lines, what would it be? Here's your shot.
Oh, okay, that's a big one, honestly. So one thing, and it's not the API itself. One thing I noticed when starting out with coroutines, as research for the Kotlin Coroutines book, and what some people still say to me when they are researching coroutines is I won't say a lack of documentation, but kind of so. So there's a lot of documentation, and literally everything is documented within the API. But there is quite a lot of things to cover. There are many concepts to cover, as I've been talking about them for a lot of time. There's the coroutine scope, and then the builders, the context, the jobs, and so on and so forth. There's just a lot to take in as the very basic, thing to achieve with coroutines. I would personally try to see if there is another way where you can practice that, or maybe just like a way to ease into coroutines, and maybe just a way to try to show how coroutines perform over other things like Rx or maybe async tasks and things like that. So I know there's been a lot of posts by Roman Elizarov, and I love them. They are really in-depth, and they explain why coroutines are, behave like they do, and why there is a need for coroutine scopes and so on and so forth. But those articles, or all the documentation can be quite overwhelming for a beginner developer. And what's happening now is more and more things in Android are coroutine powered. So as you may know, Room has coroutine support, Retrofit has coroutine support, the view models have coroutine support with the view model scope, and architecture components are more and more coroutine friendly. It would be great if there is just a lot more information on why you should use this concept over the other, and why we are switching to coroutines for a room instead of, for example, live data or something similar. So I can't really think of anything else, but just more information and more tutorials, more guides to using coroutines and why they would be better over some concept or something else we used previously.
So the learning is that first step of learning curve is fairly high.
Yeah, so I think it's a bit high if you're just a beginner developer or even intermediate who hasn't read up on a lot of things like executors in Java or just general threading mechanisms, or if you don't really know about operating systems a lot, if you haven't had any college lectures or things like that, previous education, it may be a bit high because you see all these concepts, and the very basic example is, okay, you can use the coroutine scope and use launch, and this is in a different thread. That's cool, but what is underneath? Or at least that's what interested me. What's underneath and how does this work? And if you try to delve into documentation, you just might bury yourself within all the crazy things that are going on. So maybe just a simpler way to ease users into it would be really great to have.
Philip, that is a lot of information to absorb, and I think that we really dove deep into that. I will admit my poor little iOS eyes glazed a few times trying to follow it, but I think Alex, you did a wonderful job helping us take that apart and learning a lot about it. In the meantime, Alex, you have been preparing for the new Flutter episode that's coming up by doing a little bit of Flutter playing. What have you discovered so far?
Yeah, so I've been working on some personal apps, and I decided to use Flutter for them because I wanted them to be on iOS too, and it's cross-platform, so that's nice. What I've discovered is that Flutter kind of makes it a joy to build UI in a way that I had kind of forgotten about. It makes me a little ashamed to say it as a hardcore Android supporter and Android engineer, but making UI with Flutter is just, it's so pain-free and so wonderful. So now I'm finding as I go to line up my constraint layout, or I'm adding my recycler view in, I'm really sitting there going, ooh, this is a lot of code. I'm adding a lot of stuff for this list. So it's been a really fun experience. And it's been, so Flutter uses Dart, which has also been a learning curve, kind of in the opposite direction. I have to admit that while I like Flutter, probably wouldn't choose Dart as the #1 language to use, but it's mostly been fine. It's the sort of language that feels like it doesn't really get in your way. It's not offering all of this amazing, cool stuff. It's not this next generation language that lets you do these crazy things with your types or have wild, expressions, but it doesn't feel like it really blocks me as I'm building my personal apps. So it's been a pretty good experience. It's definitely something that I'm looking forward to tinkering with more, and I'm definitely looking forward to the episode too.
Yeah, it's going to be a lot of really interesting stuff there. I'll be curious to learn more about Flutter, especially because I've got my iOS app that I need to put on Android. And unfortunately, it sounds like Flutter is one of those ground up kind of things, not I can just adapt and move across. So we'll see how that goes. Philip, I want to thank you for your time. You can find Philip online at Twitter at FILBABIC, Phil Babić, which is completely different from Filip Babić, which I just mangled horribly. Alex is on Twitter at AlexSullivan444, almost never. And I am found as Podcast Dru, that's DRU, on Twitter, again, rarely, just because everything else is going on. In the meantime, I want to thank Filip for your time, and thank you for joining us on the show.
Yeah, thank you for having me. This was amazing.
This was just a lot of great information. Coming up in 2 weeks, our next episode with Lee Morrell Sonnenschein, we'll be talking about Swift UI in production. Coming up in 4 weeks, the next Android episode, we're going to have Victoria Gonda on talking about Android test-driven development. So that's going to be very helpful. I realize that we go Android one episode and iOS next episode, and a lot of our Android episode listeners don't really want to know what's on the next iOS episode. So I figured we'll just tease 4 weeks ahead. But that is it for this episode of the formal podcast episode. Again, if you are listening to the podcast episode, check us out on YouTube for the YouTube after show. In the meantime, I am Drew Freeman. Thank you, Alex Sullivan. Thank you again, Filip Babić. And we are going to return to the Emerald Castle. Ray, back to you.
And that's a wrap. Thanks again, everybody, for listening to the RayWenderlich.com podcast. We hope you enjoyed it, and don't forget to leave a rating on iTunes. See you next time.